All right, folks, welcome once again. So welcome to week 2, right? Week 2 of our 3-week course. This is day 6 of our course here. And today we'll be starting module 6, right? Module 4, I'm sorry. And this is on networking, right? And mainly we'll be talking about mainly we'll be talking about VPCs, virtual private cloud. Okay, so this is where we are in the course, right? So we've done EC2, which is under the compute category, and we have done EBS, S3, and a few other services under the storage category as well, right? So these are uh, core infrastructural elements, right, which you will be using in all your applications, right? So you have to use EC2 no matter what type of application you're using. EBS goes along with EC2, and S3 is a very versatile service. I'm sure you'll be using S3 or one of its storage classes pretty soon. Okay, so today we look at module 4, and here what we're talking about is the networking services. There's a bunch of them, right? But we'll spend almost all our time, right, on VPC, virtual private cloud. This is a very important service because it is becoming the default way. It's becoming the default way of using AWS. When AWS first started, VPCs were not there, right? And subsequently, these were added perhaps in response to demand from some of the larger companies, more security-minded companies, right? But now the feeling is that, why not use this for everybody, or rather, why not everybody use VPCs? They are better, right? They are better from a security point of view. So, so it makes sense for everybody to use it, and therefore, AWS seems to be nudging all its customers towards using VPCs. Okay, so that's the reason it's a very important topic. All right. Okay. So let's look at the objectives of this session. Okay, by the way, we have 2 hours for this module because we needed an extra hour for the previous module, right? Module 3. So we have only 2 hours. So today's session will be on module 4. We should try and finish this module today. Okay, so what are the objectives of this module? So the objectives of this module really is to get you going with a VPC, right? And especially we'll be looking at a scenario. There are 4 common scenarios, and we'll look at scenario 2, and we'll implement that scenario. Right, so basically we have to implement a VPC that has a public subnet, a private subnet, and of course we're explaining all these things, right? So it'll have a public subnet, a private subnet, and then we have to sort of set up our servers inside of the VPC. Okay, so after the end of this module, you should be able to create your environments, right? Whether it's test environment or production environments in a VPC of your own. Okay, so that's the goal. But before we get there, we need to understand a few things, right? We need to understand things like, first of all, what is a VPC? Why is it such a good idea, right? What are the benefits? We'll also understand the components of the VPC. What is the structure of the VPC? What are the different components? What is the function of each component, right? So we'll understand that, and then we'll talk about 4 common scenarios. Right, these are published by AWS. They're probably seeing their customers using VPCs in this manner, right? So there are 4 common scenarios, and we'll understand each of those, when to apply, when to use which scenario. Okay, and then we'll implement one of them. We'll implement the second scenario, which has 1 public subnet and 1 private subnet. Okay, so this is the plan. We'll probably be spending the whole time on VPCs, right? If we have some time in the end, we'll discuss a bit of direct connect. Okay, so that's the plan. Now, so we'll use this sheet, mod 4 VPC. This is what we'll use for Q&A. And like we discussed on Friday, we can also spend a little bit extra time, right? After our session today, we can spend a bit more time on a review of week 1. Basically, if you have any questions, you might have used the weekend for practice, maybe for review, maybe, right? So maybe you have some more questions on what we did last week. right? So if you have questions, we can spend a bit more time after the 2 hours that we have now. Okay, so for that we'll use this this sheet here, week 1 review. All right. Okay. So so let's get started. Yeah, sure. So I'll send you the link. Let me. Some of you are asking for the link. Let me send you the link here, and okay. So here's the link. Here's the link, and now let's talk about VPCs. Okay. So first of all, right, what is a VPC, and what's the big deal, right? Why do we want to use VPCs? Okay, so here you can see in this slide here, right? So you have on the right side of the internet. So the stuff in the middle, this cloud here in the middle is the internet, right? On the right side you have your corporate network, right? Your offices, your network, right? So that's on the right side. On the left side you have this VPC, virtual private cloud. Inside of this, you can see there are sub networks, right? Subnet. You can have more than one subnet as well. And then inside of the subnet, you have your instances. These could be EC2 instances, RDS instances, and so on. Okay, so so it looks like the same stuff, right? It looks like you have servers in the cloud, you're accessing them from the corporate network. But there's a crucial difference here. What happens is the VPC actually is an isolated network. Okay, it's not connected to the internet. All right, it's not connected to the internet. You can make some parts of the VPC connected to the internet. You can do that, right? But in general, a VPC is something that is disconnected from the internet. It's a private network, okay, and therefore it is more secure, because even if an attacker knows your server password, right, has your private key, they can't connect to any of the instances because it is simply not connected to the internet. Okay, so that's broadly what a VPC is. Now you can connect, right? You have to connect to your own private cloud. You can do that using, in this case, you can see there's a VPN connection, right? VPN connection. So you need some components on the cloud side, a component VPN, a customer gateway on your side, and that way you can establish an encrypted VPN connection, and in this way you can connect to your cloud, right? But others, external people, cannot connect to servers in the VPC because it is simply not connected to the internet. Okay, this is how a VPC works. But before that, right, a little bit of history. So and also, what is a private cloud, right? This is a virtual private cloud. Why is it virtual? And first of all, what is a private cloud? Okay, so what happened is when cloud first started sometime in 2006, right, 5 or 6, something like that, when AWS first came out with their services, it was a public cloud, right? And public cloud simply means that anybody anywhere in the world can create an account, right, and set up some resources and start accessing the resources, right? And the servers and storage are all on a shared infrastructure, right? So these are very large regions, very large data centers, and the equipment is basically shared with anybody who wants to become a customer of AWS, right? So it's shared equipment. It's open to anybody, right? And because it is shared, by the way, it's quite cheap as well, right? And that's what a public cloud was. Okay, and it took off mainly startups, smaller companies, right? These were the early adopters of cloud computing. Okay, and as cloud became popular, as it grew, the larger companies also took notice, right? So they liked the fact that cloud had this pay-as-you-go model. It had elasticity. It was flexible. And so on, right? So the cloud benefits are clear, and some of the larger companies also wanted to sort of benefit from that, right? Now, even cloud providers like AWS also wanted business from these large companies, right? That's a good thing for AWS, for Azure also. So both sides, wanted this to happen, right? The adoption by larger companies, in addition to the startups and small companies. But the larger companies are more risk averse, right? And also, you have to look at some of the industries: banking, financial services, insurance, for example, healthcare, especially in the Western countries, especially in the US. Right? So these industries, they may be large, but they're very conscious of data privacy, data protection, right? So you had a situation where both parties wanted to adopt cloud, right? The larger companies wanted to adopt cloud. The vendors were ready to offer services, but security, right, and privacy was an issue. Okay, so the larger companies would say, look, we like cloud, right, but we also like control, right? We would prefer a private cloud, not public, right? We would prefer a private cloud because we have control. We can make sure that the infrastructure is ours, right? We own it, we control it, and that way we can mitigate the risks of data getting out there, right? So they wanted control, but with the benefits of cloud, right? So that's what private cloud is. Private cloud is essentially cloud-like features in a network, in an infrastructure which is owned and controlled and operated by that company, right? Say a bank. Okay, so that's what a private cloud is. Now AWS would say, look, I'm not going to offer you private cloud, right? That's not my strength. That's not my forte, right? My forte is to sort of set up my own infrastructure, right? Do it at scale. So I will not be offering you private cloud. I'm not going to come to your data center and offer you my technology, right? So then AWS developed something called virtual private cloud, right? So the offering here is AWS is saying to the large companies, look, I understand that you want something like private cloud, right? You want a private cloud. I can't offer what you want, but I can give you something, something good enough, right? Something good enough, and that's a virtual private cloud. Okay, so that's a virtual private cloud. And what AWS is saying here is, look, we are giving you something very close to private cloud. In the sense that the VPC is an isolated network, right? It's not connected to the internet. If you like, you can connect it, but otherwise it's not connected to the internet, right? So you have a greater security, right? So that's one benefit. The second benefit that we are giving you here is that if you like, you can have dedicated instances, right? You can have dedicated infrastructure. Okay, which is what a lot of regulators, for example, the banking regulators would say that, look, you don't share all this infrastructure, right? Make sure that you have full control over it. You're the only ones using the infrastructure, right? Now, right or wrong, okay, some regulations are usually behind the curve, right? So technology advances faster, regulations advances slower, right? But a lot of regulators may have regulations which demand that your infrastructure be dedicated and in your control. Okay, so that's what a VPC is. It's basically a compromise where AWS is saying, look, we are giving you something like private cloud, right? We can't give it to you in your own data center, right? That would be too complex. The costs would go up. We prefer to do it on our own, in our own data centers, but it's something very close to private cloud. Isolated network, dedicated instances, right? Better security as well. Okay, so that's what VPC is, and it makes sense. It makes sense for especially, say, smaller banks, right? Smaller healthcare companies. They can't do infrastructure the way AWS can, right? Maybe some of the largest banks can, right? Some of the largest banks, they'll probably do it themselves, but most of the other people, right? Most of the other companies in the industry will. It makes sense, I think, to use something like a VPC with a vendor like AWS. Okay. So that's what a VPC is. Okay, so now let's try and understand. Next, let's try and understand, how the VPC is structured. What are the various components in the VPC, and then we'll talk about how to implement a VPC as well. Okay, so a VPC actually is a network, right? First of all, you have to understand that it's a network, and it's a private network, right? And a network consists of IP addresses, right? And those IP addresses, the stuff inside the network is interconnected, right? So one server in the VPC can easily talk to another server in the VPC, right? So it's a network, and in those networks, in that network, you can place your resources like EC2 instances, RDS instances, and so on. Okay, all right. Now, in the VPC, a VPC is typically a large network, right? It's a large network, all right, and it's what is called a Class B network. Class B network, right? It's a large network, and within the VPC, you can have what are called sub networks. Okay, and sub networks are just smaller networks, right? They're smaller networks within the larger VPC. All right. Okay, and then the subnets can be public or private. A public subnet is the one where you can connect to the subnet from the outside, from the internet, right? Whereas a private subnet is something that's isolated. You cannot connect to a private subnet at all. All right. So we'll talk more about these things, right? I'm just trying to give you a high-level picture right now. So a VPC is a network. It has subnetworks, and the subnetwork can be public, okay, connectable from the internet, via the internet, and private, which is isolated. All right. Okay. So these are the major components. Now there are other things. For example, route tables. Right. Route tables are basically tables are associated with the subnet. Okay. So you may have multiple subnets. Each subnet will have one route table, and the table has rules. Okay. The table has rules, and the rules determine how the traffic, the network packets will flow both within the VPC and between the VPC and the rest of the world, right? So especially the internet. How will the traffic flow? Whether the traffic is allowed to flow to the outside world or not, right? So those kinds of things are defined via rules in the route tables. Okay, all right. There's also access control list, which is a network level firewall, right? So remember, we have used security groups, right? Security groups. Now, in addition to the security groups, which, by the way, they remain, right? You will still use security groups even though you're using VPCs, right? In addition to the security groups, there is another firewall which is called access control lists. Okay, so these are network firewalls, network access control lists. Okay, I'm going to explain all this, right? But let's first just understand at a high level what are the components of the VPC. Okay, so VPC network, right? A large network. It has subnets. The route tables define the rules, right? The network flow will happen based on what's in the route tables. Each subnet will have one route table of its own. Okay, the access control list is a firewall, a network level firewall, in addition to the security groups. Okay, there are other components as well. For example, there's something called Internet Gateway, right? The Internet Gateway. This is a component which enables bidirectional communication between the VPC and the internet. Okay, so if a subnet has an internet gateway defined in the route table, then that subnet is a public subnet. Okay, if the internet gateway is not in the route table of that subnet becomes a private subnet. Okay, so that's a very important component. This allows bidirectional communication between the VPC and the internet. Okay, the other important component is the NAT gateway. NAT gateway, right? So this is another component which can be sort of attached to a subnet, and this is usually used by private subnets and allows for a unidirectional, right? Only on the outbound side, your servers in the private subnet can connect to the internet for things like software patches, software upgrades, and so on. Okay, so NAT gateway is a unidirectional component, whereas an internet gateway is a bidirectional component. Okay, all right. Okay, and also you have a virtual gateway. This is the one that is used to create a VPN connection, right? A VPN connection between your network and the VPC. That's possible as well. And then you have VPC peering. This is where you can connect two VPCs, right, or more. You can also have 3 VPCs, and there are different configurations possible. But basically, a peering connection is used to connect VPCs. Right? Normally, a VPC is an isolated network, but sometimes you want to connect 2 of your VPCs together. Right? For example, you may have a production environment in one VPC, a test environment in another VPC, and you may, that's normally a good practice, right? That's normally a good practice, but sometimes you may want to copy some production data into a test environment maybe, right? So in those cases, you may want to create a peering connection between 2 VPCs. Okay, all right. So these are the components. Now let's take a closer look. Let's take a closer look at these components. Okay, IP addressing, by the way, remains the same, right? So we've already discussed IP addressing, private IPs, public IP, and elastic IP, right? So those things remain the same in the VPC. All right, let's talk about subnets first, right? So subnet is a smaller network in the VPC, right? Smaller network in the VPC, and a subnet can be public or private. All right, a public subnet is the one where if you have a server in the public subnet, you can actually connect to it from the internet. Okay, and you would normally use a public subnet for something like a web server, right? So anything which has to be open to the public, right? Let's say a web server, you have your users who connect to your web server and use your web application, right? So those kinds of components, web server, or sometimes a load balancer, right? Whatever is facing the internet, right, has to be in the public subnet, right? The private subnet is something which cannot be connected to, right? You cannot connect to the servers in the private subnet from the outside, from the internet, via the internet, okay? And therefore, all other components, let's say your databases, your application servers, right? Anything which is not internet facing should be in the private subnet, right? That's better because you can't connect. There's no path. There's no network path from the internet to the private subnet. Therefore, those servers are safer. Okay, so that's very important. Public subnet and private subnet. Okay, now the route table, right, is basically each subnet. You may have in a VPC one or more subnets, and each subnet will have a route table. Okay, and the route table has rules. These are rules which define how the network traffic will flow, how the packets will flow, both within the VPC and also between the VPC and the outside world. Okay, so we'll take a look at some of the rules, and we'll understand it later. But what you have to know here is that the rules in the route table govern the flow of the network traffic. All right, the access control list is the firewall, right? It's an additional firewall in addition to the security groups that we already use, right? Security groups are used for web servers, for example. Right? All your web servers will have one security group. All your app servers will have another security group, right? So the security groups are defined usually at a tier in your stack, right? So web tier will have a security group, app tier will have a security group, DB tier will have a security group, all right? And the ACL is actually defined at a network level, so at a subnet level, for example. Okay, so this is another layer, another firewall, right? Which makes it's another reason why VPCs are more secure. They're better. One, because they can be isolated from the internet, and two, because there's another layer, another firewall that is available here. Okay, now the ACL firewall works a little bit differently. Okay, it works differently from the security group. For example, here in the ACL, the rules have to be created in an ordered fashion. Okay, and if the rule matches the packet, further rules are not evaluated. Okay, so it goes one by one in order, and if there's a match, it doesn't go any further, right? Whereas in a security group, it's not like that. In a security group, all rules are evaluated. Okay, so even though this is a firewall at a network layer, it also works a little bit differently. Okay, then there's a NAT gateway, right? So I think you should ignore the NAT instance. Okay, a NAT instance is where you have a server which you have to maintain and scale yourself, right? So it's better to use a gateway which is a managed service, right? So you can ignore instance, just look at the NAT gateway, and the main function of the gateway is to allow for servers in the private subnet to go out to the internet, okay, for things like security patches or software downloads. Okay, so it allows for unidirectional, one directional, only on the outbound side, right? Traffic from the private subnet to the outside world. Okay, this is an important component for private subnets. All right, let's skip this one. Okay, then there's peering, right? A VPC peering is to allow connections between two VPCs. Okay, you have to peer them because normally a VPC is isolated, right? It's an isolated network, and it doesn't talk to any other network, right? Whether the internet or any other VPC as well, right? But if you like, you can connect, you can peer two VPCs, and you can also have other VPCs. You can have a three-way VPC as well, right? So you can do all those things. But basically, one peering connection will connect two VPCs. Okay, and the VPCs can be in different AWS accounts as well. All right. However, they have to be in the same region. They have to be in the same region. Okay. Also, the IP addresses of the two VPCs should be distinct. Otherwise, you'll have an IP address conflict. Okay, the internet gateway. I think it's the last component, right? This is the last component. The internet gateway is a component which allows bi-directional communication. Okay, bi-directional communication between the internet and the subnet Okay, so this is the component which makes a public subnet a public subnet. Okay, so if a subnet has an internet gateway defined in the route table, then that subnet becomes a public subnet. All right, so this is a very important component in a VPC. All right, okay, so these are the various components, right? These are the various components. Let's take a look at this picture once again, right? Please try and recognize this. Now, VPCs in general, people struggle with this a bit, okay, because it's mainly a networking topic, and people are usually exposed to applications, databases, application servers, and so on, right? But they're not exposed so much to networking concepts, right? So if you're not understanding all this right away, don't worry, right? A lot of people in this group will be the same boat, right? I am also in the same boat. I'm not exposed so much to networking concepts, right? So don't worry about this. Try and absorb at a high level what this is, right? These are networking services, VPC, okay? And these are the major components, right? It's enough if you understand the major components, okay? At this point. And also, we'll talk about 4 simple scenarios. And there's also a wizard which helps you create VPCs in a very simple manner. Okay, so it'll get better, right? It'll become simpler. At this point, let's just understand at a high level what a VPC is. Okay, so these are the components, right? These are the major components. Now let's talk about some common scenarios. So there are 4 common scenarios. Okay, there are 4 common scenarios, and let's take a look at them. Right, let's take a look at them. In fact, let me show you the scenarios using the AWS documentation. Okay, so just find the scenarios page. Right, this is the home page, and there are 4 scenarios that we are talking about here. And let's look at them one by one, right? Let's look at them one by one. This will give us a visual understanding of a VPC as well. All right, so this is scenario 1. Let me show this to you in a larger, let me open the image in a different tab. All right, so this is scenario 1, right? And scenarios are basically commonly used configurations, right? They're commonly used configurations. That's what these scenarios are. Okay, and we'll look at all 4, and then depending on the nature of the application, you can decide which one is a fit, right? Is a fit. Okay, so this is the first one, and it's quite simple actually. There's one VPC, and there's the VPC has one subnet, right? It's only one subnet, and actually this is a public subnet. It's a public subnet, all right. And it has one EC2 instance in the subnet, and because it's a public subnet, it's likely to be, this server is likely to be like a web server, right? It's going to be a web server. It's open to the public, which means you have a public-facing web application or a website running on this server. Okay, this is scenario number 1. Very, very simple. All right, the next scenario. Okay, so this is scenario number 2. This is a good one. It's slightly more complex. Okay, so this is scenario 2, right? And you can see this one has two subnets, right? It has two subnets, one public and one private. Okay, one public, one private. And what happens here is the web server. Let's say you have a web application, so the web servers will sit in the public subnet, right? And everything else, for example, here you have the database servers sitting in the private subnet, right? If you had app servers different from the web servers, those also would be in the private subnet, right? So public subnet should have the minimum. The only things that you need to be internet facing, right? Only those things should be in the public subnet. Everything else goes into the private subnet. Okay, this is scenario 2. All right, now 3 and 4. 3 and 4 are very similar. They're very similar to 1 and 2. Okay, they're very similar to 1 and 2, except the only difference is that, for example, this one, scenario 3, is similar to scenario 2. You have two subnets. One is a public subnet, one is a private subnet, right? It's the same thing, except you have a VPN connection. Right? So you have a VPN connection between the corporate network, right? Between the corporate network and your private subnet. Okay, so this is the only difference, and this is good when you want to connect directly to your servers in the private subnet via a VPN connection. Right? So for maintenance purposes, you can do that. This is running a public application, right? Because your web servers are in the public subnet, which means you want your customers who may be anywhere in the world to connect to your web servers, right? So in that sense, it's very similar to scenario 2, but what's different here is the VPN connection allows you to connect directly to servers in the private subnet. All right, so this is scenario 3, similar to scenario 2. And finally, you have scenario 4. And this one is actually similar to scenario number 1. Okay, this one is similar to scenario number 1. There's only one subnet, right? There's only one subnet. But the difference is this is actually not a public subnet. It's a private subnet. And you're connecting to it from your corporate network using a VPN connection. Right, so this would be useful, for example, when you have some internal applications running on the cloud, and only your employees, right? So people inside your corporate network need to connect to that, need to use that application, right? There's no need for that application to be used by anybody else. Therefore, it's not a public subnet. Okay, so this is an introduction. Let me stop here. I know that this is a little bit difficult topic, right? It's a difficult topic mainly because people are not very familiar with networking, right? Networking used to be before the cloud. Networking generally is done by different teams, right? And people who work on the application side, right, or general IT don't have that much of exposure to networking, right? So that's why this is a little bit unfamiliar, I'm sure, right, to many of you. So let me stop here, right? We've seen an introduction. We've discussed a short introduction to VPCs, right? What they are, why do we need them, and we've looked at the components. We've looked at these 4 scenarios, right? So let me know what's on your mind, right? Maybe a lot of things are not clear. So let's let's do a little bit of Q&A at this stage, okay? After this, I'm going to explain the scenarios in more detail. Okay, I'm going to talk about the granular aspects, each component, right, in the 4 scenarios, okay? And then finally, we'll implement one scenario. So we'll see how to create a VPC, how to set up our servers in the VPC, okay? So all that we'll do, but first let's do some Q&A here. Okay, so let's look at these questions. So Gajendra, can you explain the difference between internet gateway and the virtual gateway? Yeah, so the internet gateway, right? It's basically, it is used to make the subnet a public subnet. Okay, that's how you have to understand this. So what happens is you have bidirectional communication as well, right? So servers can communicate to the internet with the internet. They can go out, download some stuff, for example, software patches, right? So that's possible, and also from the internet into the VPC, okay, into the subnet. So you can do an SSH connection, for example, right? So bidirectional, both inbound and outbound. So inbound and outbound will be possible uh, via the internet gateway. Okay, so this is one, and then the virtual gateway is used for VPN connections. Okay, VPN connections. So this is an encrypted connection between your network, okay, between your corporate network and the VPC or a particular subnet, right? A particular subnet in your VPC. All right, so they are both gateways. Okay, they are both gateways, but they have different functions. Okay, Gajendra, does Edureka provide self-paced learning courses on networking concepts? Or you can suggest any material. Okay, let me come back on this. Right, right off the bat, I don't, I don't have anything to tell you right now. Let me come back to this. Yeah, so we'll look at the 4 diagrams once again. Okay, we'll do that. Don't worry about this. We'll look at especially we'll look at scenarios 1 and 2 in more detail, right? And we'll also implement scenario 2. Okay, 3 and 4 are similar to 1 and 2. Okay, so if you understand 1 and 2, 3 and 4 are simple to understand. Right? The only difference is 3 and 4 have a VPN connection. Okay, so we'll focus on 1 and 2, and then we'll implement scenario 2. All right, so this is coming up. Okay, Chandra, when we create an EC2 instance in the free tier, it has an associated VPC. Why is it required for the public cloud? Yeah, so VPC is becoming the default. It's becoming the default. Basically, what is happening is VPC, like I said, was probably started for larger companies, but now the thinking is everybody should use it. VPCs are better. Okay, they are better. So VPC is more secure, right? It's best if you use it. Okay, therefore AWS is nudging, right? Is nudging everybody to use VPCs only, right? In the future, you may not have what is called EC2 Classic, right? EC2 Classic is the non-VPC EC2, right? So you may not have EC2 Classic at all. All right. In fact, I think in your account, if your account is new, you may not be able to create instances outside of a VPC, right? I can do that because my account is very old, right? But it looks like for newer accounts, they're not even allowing instances to be created outside of VPCs. Okay, so there's no problem, there's no downside. It is a bit complicated, right? That's the downside of using a VPC, but once you learn it, it's fine. It's the same thing. Okay, but in terms of security, it's much better. Therefore, it makes sense for you to use VPCs right away. Right? Don't try and do it outside of VPCs. Okay, even if you can, just use VPCs. It is very, very important. Okay. Next question. Scenario 1: you created a security group, but it was not appearing when I tried to select via select a security group. Yeah. So we'll see this. I'm going to show you a demo. Right. Let us wait for a demo. So I'm going to show you all this. It will become clear. Mainly what happens is here the security group has to be created for a VPC, right? And then it becomes visible. So if it's not visible, that means you created your security group elsewhere in a different VPC. Okay, so mainly the reason here is that the SG has to be created in the specific VPC. Okay, but I'll show this to you. Okay, next question, Rao, scenario 1. How do we know by looking at it? It's a public network. Yes, I'll explain that. Okay, so I'm going to explain the details. I'm going to explain the details of the 2 scenarios, especially right 1 and 2. I'm going to explain that. So let's just wait for this. Okay, Web, what is that? /0, what does it mean? So that's, I think you'll find it somewhere in the security group settings, right? So you should explain where you are seeing this, right? So that people have a context as to what this is, right? But you probably are looking at it in the security group source IP address, right? So that basically refers to uh, the IP address range, right? IP address range. Okay, and /0 usually refers to unrestricted access, any IP address. Right? So yeah, so we'll talk about it. We'll talk about this, right? I'm going to show this to you as well. Okay, okay, folks. So now let's talk about the four scenarios once again, right? This time I'm going to go a little slower, and we'll talk about the details of each scenario, right? Especially 1 and 2, because as you can see, 3 and 4 are very similar, right? They're very similar except for the VPN connection. So let's talk about scenario 1 here. Okay, so this is scenario 1. Right now, let's try and understand this in detail, right? And also we'll talk about each component here. Okay, okay. So first of all, you can see the outer box is the region, right? It's the region. So a VPC is always within one region, right? VPC cannot straddle multiple regions. Okay, very important to remember. VPC always within one region. Okay. The next box, this box is the VPC, right? And you can see the IP address range here. It says 10.0.0./16, right? /16. So the /16 is the what is called the network mask, right? Network mask. And you can, these are basically CIDR, what are called CIDR notation, right? Just take a look at the Wikipedia page here, and this explains. This is nothing to do with AWS, right? These are standard networking concepts. And if you just on this page, if you just go down, you'll find a table, right? These are the IPv4 CIDR blocks, right? And basically, when you have a mask of /16, this one here, the subnet, the mask is actually this one, 255, 0 and 0, right? And basically, right, you can sort of read about what a mask is and how the computation happens. But what you have to know really is that a /16 network simply means that there are approximately 65,000 IP addresses possible in this network. Okay, so it's a large network. It's called a class B network. Okay, it's called a class B network, and this has approximately 65,000 IP addresses. Okay, that's what /16 means. Okay, all right. So right now, this is all you need to know. You can read up about networking concepts, in due course, right? But at this point, all you need to know is that a VPC is a private network, right? It's a private network, and the IP address range tells you that it's quite a large network. It's a class B network, and it has potentially 65,000 IP addresses. All right. Now, next, what else? Right? You can see there are two orange boxes, dotted line. Right. So this is the availability zone. Right. You can see there's availability zone 1A, rather. Right. And then another one, availability zone B. Okay. And the subnet, you can see the subnet here. Right. This is a smaller network within the VPC. Okay. And the subnet is actually in zone A. Right? What this means is the subnet can only be within one zone. It cannot straddle multiple zones. Okay, a VPC can only be within one region. It cannot straddle multiple regions. And a subnet can only be within one zone. It cannot straddle multiple zones. Okay, all right. Also, take a look at the IP address range of the subnet. Right, so there's 10.0.0.0/24. Right, 24 is the subnet mask of the, or rather the network mask of the subnet, right? So if you look at our table here, /24 is this one, right? This means a mask of 255s and 0, right? And this is called a class C network. It's a very small network, right? Class C network. And this has approximately, well, exactly 256 IP addresses, right? Not all IP addresses are available because some of them are reserved, but you have 256 IP addresses in a subnet, potentially, right? Potentially, you can have 256 IP addresses in a subnet. All right, okay. So now, right, I hope it's becoming clearer, right? You have a VPC, which is a private network. It's a large network, class B network. The VPC can have one or more subnets, right? These are smaller networks, typically, class C networks, 256 IP addresses, right? The VPC is within a region, the subnet is within one zone, right? But a VPC can have multiple subnets, and the subnets can be in different zones. Okay, so all that is possible. You can have many subnets, many zones, all part of the same VPC. Okay, all right. Now let's take a look at this route table. Right, this is the route table, and the table is associated with a subnet. Right, so when we look at the VPC and we define the subnet, then we have to sort of specify what is the route table for that subnet. Right, it's mandatory. Each subnet must have a route table. Right, although multiple subnets can have the same route table as well. Right, but one subnet must have a route table. Okay, all right. Now, what are the rules here? You can see there are two rules defined in the route table, right? And the rules govern how the network traffic will flow both within the VPC and between the VPC and the outside world, right? So here, the first rule, this one, the first rule here on the top, which says 10.0.0.0/16 and a target of local, right? So the IP address range is the VPC IP address range, right? And the target is local. And what this really means is that the network traffic is free to flow within the VPC, right? Within the VPC, network traffic will flow. One server can communicate with any other server very easily as long as it's in the same VPC, right? It can also be, the two servers can also be in two different subnets, right? They can be in two different availability zones. That doesn't matter, right? Communication between servers within the VPC is allowed, right? It will flow. There's no problem. Okay, that's what rule number 1 says. Okay, the second rule is more interesting. What it says is the IP address is 0000/0. This normally means any external IP address, right? Anything outside the VPC, and including the internet. Right, mainly the internet, because otherwise it's not connected. This VPC is not connected to the rest of the AWS cloud, right? So when we say 0000/0 here, what we mean is the internet. Okay, and you can see the target here is the internet gateway, right? So IGW -ID. So you'll have a specific internet gateway with its own ID here defined here. And what this is saying is, look, if you want to talk to the outside world, you have to go via the internet gateway. That's what that rule says, right? And the internet gateway is a component which actually allows bidirectional communication, right? So this rule effectively means that this subnet is a public subnet, right? And what this means is, if you want to say SSH to this instance, or you want to connect to this instance on port 80, right? You'll basically be going via the internet gateway, right? Via the internet gateway to the public subnet and then to the EC2 instance. Okay, and same way, the instance can also connect to the internet. For example, if it wants to, if you want to download some security patches, you can run a command on the instance. It will go out to the internet via the internet gateway, download the software patches, and then you can install them. Okay, so the internet gateway allows bi-directional communication, both inbound and outbound, right? So that's how it works, right? So if in the subnet's route table you find a mention of the internet gateway, right, that means the subnet is a public subnet, right? If the internet gateway is absent, then the subnet is a private subnet. Okay, all right, all right. Now, a few more things, right? A few more things before we go to the next scenario. This one, you can see here, there's a firewall. Right? There's a firewall here. This you can consider to be the network ACL, right? Network ACL. So there's a firewall at the subnet level. Okay, we'll talk more about this later. But just remember that you have a security group at the instance level, right? So there'll be a security group around this, protecting this server, and then in addition to that, there'll be a NACL, there'll be a network ACL, another firewall at the network level as well, right? So you have two layers. You have two layers of security. Okay, all right. Otherwise, there's an elastic IP address. You know that an elastic IP address can be associated with an EC2 instance, right? So that's the same thing that we've seen before. Nothing new here, right? This one here, 10.0.0.0.6, is the private IP address of this instance. That also we've seen before, right? Nothing new here. Okay, all right. So this is how scenario 1 works. In this scenario, what you can do is you can have a server in the public subnet. The server will normally have maybe a web application, right? A web application, port 80, port 443, HTTPS, HTTP, right? You can also maybe want to make some SSH connections sometimes, right? So all those things are possible because the server is internet facing. You can connect to it from the internet. Okay, all right. So this is scenario number 1. Let's talk about the second scenario. Okay, so this is the second scenario, right? And here, what's happening is you have two subnets, right? You have two subnets. One is public, one is private. Now let's take a look at the differences, right? Everything else is the same. VPC in a region, same IP address range here. It's a class B network, right? Both subnets are in the same availability zone, right? Zone A, but that's not important. You could have the private subnet in a different zone, right? That doesn't matter, right? It just happens to be the case here that both subnets are in the same zone. Okay, now if you look at the private subnet, right? This is what is new here. So in the private subnet, right, you have a route table, right? And in the route table, you can see there are two rules once again. The first rule is identical to the rule in the public subnet's route table. Right? It's the same thing. Local traffic will flow within the VPC, right? So this database server can talk to the web server, or rather in the other direction, right? Web server can talk to the database server, no problem, right? No problem. This rule allows for traffic to flow within the VPC, even across different subnets. Okay. The second rule says 0000/0, which means external IP addresses in the internet, right? And there, the target is not the internet gateway; it's the NAT gateway, right? It's the NAT gateway. Okay. So what this means is, first of all, in this route table, the private subnet's route table, there's no mention of the internet gateway, right? Since there's no mention of the internet gateway, that means that this subnet is a private subnet. Okay, absence of internet gateway implies that it's a private subnet. Okay, so then what is this? What is the NAT gateway? Right. So instead of the internet gateway, we have the NAT gateway. So the NAT gateway actually allows for unidirectional, right, on the outbound side only. So for example, on this database server, you might want to install security patches, right? So what you want to do is you want to connect from this server, you want to connect to the internet, download some security patches, and then install them, right? So you're looking for outbound connection to the internet, right? You don't want inbound connections. Okay, that's what, that's the whole purpose of VPC, right? That's the whole purpose of a private subnet, to block inbound traffic, right? So the NAT gateway allows for outbound traffic only, right? And that's why you have for the private subnet, a NAT gateway mentioned in the route table, right? Now you might be wondering, why is the NAT gateway sitting in the public subnet, right? It's used by the private subnet, but why is it sitting in the public subnet? Okay, so that's true. So this is confusing, right? Why should it sit in the public subnet when it is for use by the private subnet? Well, it sits in the public subnet because it has to go and talk to the internet, right? The only way for it to talk to the internet is via the internet gateway, which is only available with the public subnet. Okay, so it sits in the public subnet, but it is used by the servers in the private subnet. All right, okay, so that's the major difference between scenario 1 and scenario 2. All right, okay, now let's take a closer look here, right? So you can see here the private subnet has a range, IP address range. It says here 10.0.10.10 /24, right? The other subnet has 10.0.0.0/24. So you can see the IP address ranges are different. Okay, the subnets have a distinct IP address range, which is how it should be, right? Which is how it should be. You can't have the same IP address range, otherwise there'll be conflict, right? IP address conflict. Communication can't be sent because there are two servers with the same IP address, right? So you can't have that. So normally subnets, 2 subnets or 3 subnets or 4 subnets, each will have a distinct IP address range, right? But the IP address range, IP addresses should be within the overall VPC range, right? So the subnets, have to all fit into the larger VPC network. Okay, all right. So this is scenario 2. Scenarios 3 and 4, let's leave them alone, right? The only difference there is the VPN connection, right? So let's leave that alone. Let's just focus on 1 and 2. I hope I hope this is clear, right? Or beginning to become clear. All right. Let me stop here once again. Maybe you have some more questions. Okay. Now that we have discussed scenario 1 and 2 in a little more detail, let me stop here and see if you have any questions. Next, I'm going to show you how to implement, right? And we'll implement scenario 2, which is slightly more complicated. So we'll implement scenario 2, and I'm also going to deploy some servers, at least one server in the public subnet. Okay, so that's coming up. But before that, let's make sure, right? Let's make sure the scenarios are understood, the components are understood. All right, Chandra, NAT gateway is like a jump server to actually connect to a private subnet instance. No, not a jump server, not a jump server. So I don't know, I'm not sure what the jump server means. Okay, but I'm assuming a jump server, by a jump server, what you mean is you connect to the jump server and then connect to servers in the private subnet, right? But if, but it's not that. It's not that. A NAT gateway allows servers in the private subnet, right, to connect only on the outbound side, right, only on the outbound side to the internet, right? Use case, what is the use case of this? Downloading software or security patches. Okay, you can't use the NAT gateway to somehow, via like a jump server, somehow connect to the private subnet servers, okay, from the outside, from the internet. You can't connect to the private subnet at all from the internet, okay, and the NAT gateway will not help you do that. Okay, so it is not a jump server. You cannot connect to the servers in the private subnet. Okay. Okay, next question, Balin, we are going to assign private IP and public IP in a single instance. Yeah. No. This is normal. This is normal. So all EC2 instances, okay, all EC2 instances will have a private IP. Always, right? This is will always have a private IP address. Okay. Now you can, in addition to that, in addition to the private IP, you can have a public or an elastic IP. Right? Elastic IP is also a public IP address, by the way. Okay. So private IP will always be there. In addition, you can choose to have a public IP or an elastic IP. All right. Okay. Okay. Rao /24 means we can have 2 to the power 24 instances in that subnet. No. 2 to the power 24 would be too large. No, not that way. Right. So the computation is, you can read up on how the network mask works. Right. So look up the network mask computation. Right. But basically, you can see here in this page. Right. In this page, you can see here /24 leads to a mask of this. This is the mask, and this gives you this many. Actually, it gives you 2 to the power 8. Okay, it gives you 2 to the power 8. Right, that works out to 256. Correct. So that's what it is. It's actually 2 to the power 8, 256 IP addresses. Okay. Now, how that works, you can read up on that. But it's actually /24 translates to 2 to the power 8, which gives you 256 IP addresses. All right. Okay. Well explained. Thank you. Sure. Most welcome. Okay. So okay. So Babita, if I don't have public subnet, then where will the NAT gateway sit for the private subnet outbound traffic? That's a good question. So that's a good question. So let's see in case 3 and 4. If there's no NAT gateway here. In these things, there's no NAT gateway. Okay. Yeah. So if my sense is, I haven't actually, I haven't come across this question, right? So I don't know the correct answer, but my sense is then you can't, if no public subnet, right? If no public subnet, then NAT gateway will not be possible, right? Is my sense. You have to check this. You have to maybe try something and check it out. Okay. Now, so what's the solution, right? So in scenario 3 and let's say in scenario 3, right, you have a public subnet. Okay, but let's say scenario 4, there's no public subnet here, right? In scenario 4, there's no public subnet. So if let's say you want to download some patches on this server, what will you do? Right? Maybe you have that kind of question. So what you'll have to do is you'll have to use the VPN connection to get those patches, right? So you have to download the patches on a server in your corporate network, then use the VPN connection to get the patches on the server and do something like that. Okay, so then NAT gateway will not be possible, but other workarounds are there. So the other solution is use a VPN connection to get the patches on your servers in the private subnet. Okay, so that's an option. All right. Any possibilities to connect bidirectional in the private subnet? Yes, you can, but then you will make that subnet a public subnet. Right? All you have to do is to create a rule with the internet gateway in the route table. Right? So for any subnet, in that subnet's route table, if you have an internet gateway rule, right, that becomes a public subnet. So you can convert a private subnet to a public subnet easily, okay? But then it becomes a public subnet, which is less safe, right? Remember, in the whole thing, the whole VPC idea and the whole idea of private subnet is to isolate from the internet, right? If you're not connected to the internet, that's great. That's great from a safety perspective, right? So then be careful, right? Remember, right? Private subnet is safe. Okay, so I mean, be careful, before you do that, right? And first of all, why do you want bidirectional, right? Why do you want bidirectional, right? That's very important to understand. You know, if you want bidirectional because it's a web server, right? It needs to be open to the public. Then keep your server in the public subnet, right? Don't keep it in the private subnet. So this is a very important question. Why bidirectional? This is very important. And that too, why bidirectional for private subnet? Because then we'll be defeating the whole purpose of a private subnet. Okay, loop to row 15. Okay, so we're going to assign private IP and public IP in the same instance. We require 2 NIC cards. Can I assign my own private IP in my instance? Yeah, 2 NIC cards? No. So what happens is they do it outside, right? So the private IP actually goes to the network interface, right? Private IP is attached to the network interface. The public IP is actually NATed. Public IP is handled uh, via NAT type of rules outside the instance. Okay, so you don't need multiple cards. You don't need multiple network interfaces. Okay. However, now it doesn't mean you can't have multiple interfaces, right? Read up on ENIs, Elastic Network Interface. Okay, so this allows you can have multiple ENIs attached to a single instance, right? And then therefore you can have multiple IP addresses on a server, right? You can do all these things. There are certain use cases where you can have multiple NICs and multiple IP addresses, right? But for a public IP and a private IP on the same server, you don't need multiple NICs. Okay, all right, okay. All right. Rao, who is going to support VPC technical issues, AWS or us? No, look, in general, right? In general, AWS is a product company. Okay, they don't like to get into services. Okay, they're not going to support you in general. Now they do have plans, right? So they do have support plans. Okay, so you have to subscribe. So remember, this account that you have is a basic plan, which has no monthly cost, right? So it has no support. Okay, so the free tier plan, the basic plan, right? The basic plan has no support. Okay, you can use the forums. You can use the community forums, right? AWS forums can be used, right? But AWS will not respond to your emails or phone calls. Okay, but if you have a paid support plan, then you can look up the terms of that, and based on those terms, you can access support. Okay, in general, they don't get into services. By the way, let me share with you, right? I have never spoken to anybody in AWS on any support issue in more than 8 years or 9 years of using AWS. Okay, so just note this, right? Because look, it just works as advertised, right? It works as advertised. If you have any technical issue, you have to troubleshoot it yourself in general. If you do a Google, you'll normally find a solution, right? So it's usually simple once you cross the initial barriers, right? It's usually very simple. So I think this is an important point. I have never used AWS support, okay, or never needed AWS support, okay, because it just works. All right, okay. Rama, can we set inbound and outbound rules instead of creating private subnet? No, but what is the use case, right? What's the use case? What kind of rules are we talking about? Firewalls? Are we talking about routing rules? Right? And why do you want to do this instead of creating a private subnet? Let's start with the business case, right? And then we can understand what you're trying to do. Okay, yeah. So, Valen, can I assign a private IP address in my instance because while launching the instance automatically shows the private IP? No, you can create your own. You can basically choose the IP address range of your VPC and subnets. Okay, you can do something like this. Because it's a private network, you can have any IP address range. That's up to you. Okay, but for example, let's say if you have this IP address range 10.0.0.0/24, right? The server cannot have 192.168, etc. Right? Because that IP address is not within this IP address range. Okay, so your server IP has to fit inside the subnet's IP address range, right? And you can define this. Okay, so instead of saying 10.0.0.0/16, you can say something like 192.168 something, right? So that you can do. But you can't have a mismatch between the server IP and the network in which it sits. Okay, so you can choose the IP address range of the VPC and subnets, and also don't do this. Don't set, or rather, you can't have private IP address distinct from the subnet range. Okay. All right. So this question here, I would like to use non-publicly accessible backend server without creating private subnet, if possible. Yeah, but look, you have not explained why you want to do this. What's the problem with the private subnet? I can understand. Yes, there is more information, right? You want a non-publicly accessible backend server, right? But why do you not want to use a private subnet? That's not clear. Okay. Now, if you want to do it, you can, of course, block it at a firewall level, right? You can, set up a server in a public subnet, right? You can do that and use the firewalls, right? You can use the firewalls to block certain types of traffic. You can do that. Okay, so that's possible. But then, is it a good idea? I don't know. Okay, all right, folks. So now, let's talk about implementation. Right, we have a little less time here, so let's move on. Now I'm going to show you how to implement something like this. Okay, we'll talk about scenario 2. Okay, because it's representative, right? Scenario 1 is very simple. It has only one subnet. So let's do scenario 2. It has one public and one private, and we get to see more basically. So I'm going to implement this scenario, right? So I'm going to create a VPC using a tool it's called the VPC wizard, right? We'll use the VPC wizard to create this VPC, right? So it will be exactly like this, a VPC with two subnets, one public, one private. And then once we create this, we'll go and inspect it. Okay, we'll go and inspect it and take a look at the route tables, for example. Take a look at the subnet. Take a look at the components like the internet gateway and the NAT gateway, right? So we'll go and inspect it. Okay, and then finally I will launch an EC2 instance, right, in the public subnet. Okay, we'll see how to launch a server in the public subnet of this VPC. Okay, and then we'll also try and connect to this server, see how all that goes. Okay, now the database server, we'll probably not have time, but in the next module, right, especially yeah, in the next module, right, which will start tomorrow, we'll look at RDS, Relational Database Service, right? So when we launch RDS instances, we'll launch it in a VPC, right? So we'll talk about private subnets and databases in the next module, okay? But here we'll definitely launch this VPC and set up a web server in the public subnet, okay? So let's see how all this works. All right. Okay. So this is our home page, right? And from the home page, let's find VPC under the networking and content delivery category, right? So let's click on VPC. Okay. Now this is the VPC dashboard, right? And you can see right away there's one VPC already there, right? There's one VPC already there. So let's go into this section here. Your VPCs, and let's take a look at this one. Right, there's already one VPC. What is this? Okay, so you'll find, you know, if you go into your account, you'll also find a VPC there, right? And you'll find one VPC in every region, right? So if you go to any other region here, you'll find a VPC in every region, right? So this VPC is called the default VPC. Okay, it's called the default VPC. If you look at the subnets, there are 4 here, right? One for each zone. Actually, now there are 5 zones, but earlier there used to be 4 zones. So that's why you see only 4 zones here. In your account, you may find one subnet for each zone in that region. Okay. Now, if you look at this subnet, this is in zone 1D. This one is 1A. This is in 1C. This is in 1E, right? You can see here at the end the zone for each subnet. So basically, in this VPC, you have one subnet for each zone. All right. Okay. Let's take a look at the route table of this subnet here, right? So just ignore this one. Just ignore this peering connection. Just ignore this line. But you'll find, you know, in your account, you'll find 2 rules, right? This one is the local rule, which allows traffic to flow within the VPC. And then this one is the external rule, which talks about the internet gateway, right? So what this means is this subnet is a public subnet. All right. Okay. If you look at the other subnet, they are also public subnets because they also have the internet gateway, right? So you can see here, this is also public subnet. All subnets are public subnets, which is, by the way, a bit strange, right? Because a VPC is meant to be private, but here all the subnets are public subnets, right? That's a bit strange. All right. Okay. So the reason is this VPC is actually meant for you to, you know, to start using AWS in a simple manner, right? It's there for your convenience, especially for beginners, right? So, you know, in this course, whenever we have set up an EC2 instance, right, in module 2, for example, in module 3, for example, as well, right, we have always set up our instances in this default VPC, okay? And you can use the default VPC when you're learning AWS, right? That's fine. But remember, this VPC is not secure, okay? It's not secure because you can see the subnets are all public subnets, okay? In fact, if you look at the network ACL, this is the network ACL, right? The network firewall, and you'll find, just ignore this rule, but you'll find here, rule number 100 says all traffic, all protocols, all ports, all sources, right, are allowed, which means this firewall is effectively dead, right? It's not doing anything. It's allowing all traffic in. Okay, so basically this VPC is there for ease of use, like to help you get started faster, right? So that you don't run into networking problems on day 1, right, and get frustrated with AWS, right? That's why this VPC is there. It's a simple VPC, very open, very insecure, right? only meant for learning purposes. All right, so that's very important to note, right? This VPC should not be used for any serious environment, right? Not even for your test environments. Forget about production environments, right? Don't even use it for development environments. Don't even use it for test environments because it is simply not secure. All right. Okay. So important point here. Also, remember, don't delete this VPC because people you remember we have to clean up, right? We always have to clean up. We have to be disciplined so that our cost is under control. But in that hurry to clean up our resources, right? You may end up deleting the default VPC. Don't do that because then you have to contact AWS support to get it back, right? So remember. Be careful, don't delete the default VPC, right? You can delete all of the VPCs, you should delete all of the VPCs to cut the cost, right? But don't delete the default VPC. All right, okay, now let's go to the VPC dashboard, right? So in the home page, in the dashboard page, you'll find this tool here, VPC Wizard, okay? You'll not find this anywhere else, right? So you may be in some other section, you may not find the wizard, right? So remember, it's in the VPC dashboard. All right. Now the wizard is a tool. Okay, the wizard is a tool which will automatically create one of the 4 scenarios, right? So we can choose a scenario, and the wizard will create it for you. Okay. Now you can create your own VPCs. You can create, say, this one, scenario 2 VPC on your own by hand, right? Which means you first create a VPC. Then within that you create this subnet, next you create this subnet, right? Then you create a route table, define the rules, connect the route table to the subnet, right? All those things you can do one by one, okay, by hand. You can do that. However, it needs a bit of expertise, right? It's likely that it'll need a lot of effort. You'll make some mistakes. You'll have to do a lot of troubleshooting, okay? So that's why it's best if you use the wizard, right? Initially, at least, right? While you're getting familiar. Always use the wizard. Don't try to create a VPC on your own. All right, you can do that later, or you can customize the VPC once you've used the wizard to create it. Right, that you can do, but don't try and create a VPC right away on your own. All right, let's use the wizard. Okay, so let me click on this wizard here. Right, you can see there are 4 scenarios here. The same 4 scenarios. This is scenario 1. This is scenario 2, 3, and 4. Right, so you can choose any of these and then run through the steps of the wizard, and then the wizard will create the VPC for that scenario. All right, that's how it works. Now here, let's create scenario 2. Right, we are interested in creating scenario 2. So I'm going to select scenario 2 here. All right. Now it's very simple. The wizard is very simple because it's supposed to automate everything, right? Almost everything. So we don't have to fill much, right? We don't have to fill too many details here. It has lots of default values, and those default values are usually fine. All right. However, for the NAT gateway, we need an elastic IP address, right? A NAT gateway always needs an elastic IP address, right? So we don't have that. So let me exit for a moment. We'll come back. Right. First, let's go to elastic IPs here, and let's allocate. Right. Let's allocate an elastic IP first. All right. This is our IP address allocated. Right. It's not attached. It's not associated to anything right now. Right. But we have allocated it at the moment. Okay. Now let's go back to the dashboard. Let me use the wizard. Choose scenario 2. Right. And now just give it a name, scenario 2, let's say, and we'll associate the elastic IP to the NAT gateway, right? That's it. These are the only 2 things you need to do, right? But let's take a look here. What's happening? So we're creating a VPC with this IP address range /16 means class B network, right? 65,000 IP addresses you can see potentially, and then there are 2 subnets. This one is the public subnet, right? And then this one is the private subnet. All right, we've not given a preference for the availability zone, although we can. All right, but let's leave that. It's not important. All right, so this is the VPC scenario 2 VPC with a NAT gateway. Let me create this VPC. Okay, normally it will be very fast, right? The VPC will come up very fast, but it will get stuck at the NAT gateway. All right, NAT gateway is a sort of managed service. There's probably some server provisioning that has to happen, right? So that's why it takes a bit of time, a couple of minutes, right? So don't worry if you find that it's stuck here. Don't try and cancel. Just wait for this. It'll take a couple of minutes, and then it'll complete. Okay. So after this, we'll have our VPC created, right? So now we'll have two VPCs. Okay. The earlier one, the default VPC, and then this one, right? So we'll then go and inspect, right? We'll go and inspect this VPC. We'll take a look at the public subnet, the private subnet, the route tables, the ACL, the internet gateway, the NAT gateway, right? We'll go and inspect all that just to make sure everything is as expected, everything matches with the diagram that we have, right? So we'll go and make sure that everything as shown here is what we see in the web console. All right. Okay. Once we do that, we'll then try and deploy a server in the public subnet, right? Because so far, we've ignored the VPC side. When we launched the EC2 instance, we've ignored the VPC page, right? Today, we'll take a look at the VPC page. We'll select this VPC. We'll select this public subnet, right? And then we'll create the web server. All right. So we'll have to do that. Now, also, before we, create the server, we'll also have to create a security group, right? We'll have to create a security group for the web server because all instances need a security group, right? Also, the security group has to be created within the VPC, right? You can't use any security group. It has to be within the VPC. So before we launch the server, we'll also create a security group for this web server. Okay, all right, so that's coming up. Let's see. Okay, so it's done, right? You can see VPC is successfully created, right? So let's say okay here, and now you can see the VPC list. There are two, right? This one, the one on the top is the default VPC, right? And the one at the bottom is the one that we just created. All right. Okay, so this is our VPC. Nothing much to see here, all right? But you can see things like, this is the IP address range here. All right, that's it. Now let's take a look at the subnets. Okay, now there are 6 subnets here, 4 from the previous VPC, and then 2 more. This one is the private subnet, right, of our scenario 2 VPC. You can see the VPC here. This is scenario 2, right? And then this one is the public subnet of the same scenario 2 VPC. Okay, let's take a look at the public subnet. Okay, this is in zone 1B, right? It's in zone 1B. This is the IP address range here. It's a class C network, as you can see. All right. Okay, let's look at the route table. Now you can see there's a local rule, right, and then an external rule. This is pointing to the internet gateway, right? So this is a route table for the public subnet, and you can see it does match with our diagram here, right? So there's a local rule, there's a external rule, and there's an internet gateway ID here, right? This is for the public subnet. The internet gateway makes the subnet a public subnet, right? Okay. Now take a look at the internet gateway, right? So if you go to the internet gateway here, this is the internet gateway, right? This section here, you can see this one is the one for the scenario 2 VPC, right? There's another one which is for the default VPC, but our gateway is this one. Okay, so this is the public subnet, right? This is the public subnet. Okay, the private subnet, right? The private subnet, you can see here, this is also in 1B, right? This is also in zone 1B. The IP address range is different, right? It's 10.0.10/24. Okay, 10.0.10/24, whereas the public subnet is 10.0.00/24. Right? Okay, let's take a look at the route table. The route table for the private subnet, right, as expected, does not have the internet gateway, right? It does not have the internet gateway, which means the private subnet. All right. Also, instead of the internet gateway, it has a NAT gateway, right? Which is how it should be, right? Which is how it should be. As you can see here, the private subnet's route table has a NAT gateway. All right. Okay. You can also take a look at the NAT gateway section here, right? This is the NAT gateway section here. This is the NAT gateway used by the private subnet. All right. Okay. Now, one thing is very important here, right? The NAT gateway is a paid service. It's a paid component, right? It's not covered under the free tier. All right, not covered. The VPC in general is free, right? There's no cost of the VPC. You can create VPCs, you can create subnets. There's no cost there, right? But the NAT gateway and the VPN gateway, right, are paid services not covered under the free tier. All right, something for you to remember. Please, when you're practicing this, please make sure that you delete your scenario to VPC. Okay, make sure after practicing, delete your scenario to VPC. Make sure the NAT gateway is deleted. Otherwise, you'll find a cost in your bill. All right. Okay. So we have inspected, right? We have inspected this VPC, right? We've seen the VPC itself. We've seen the public subnet. We've seen the private subnet. We've seen the route tables of the two subnets, right? We've seen the internet gateway. We've also seen the NAT gateway. All right. Okay. One more thing. We haven't seen the ACL, right? The network ACL. So take a look at this ACL here. Right? This is for the private subnet. And it's actually the same network ACL is used by both subnets, right? Now here, the ACL actually works differently. Okay, if you look at the inbound rules, you can see there are two rules, rule 100 and rule number star, right? Star is the default rule. Okay, the default rule says all traffic, all protocols, all ports from any source will be denied, right? Denied, okay? And then the rule 100 basically says everything is allowed, right? So this is, right now the ACL is ineffective, right? It is allowing all traffic, okay? It is allowing all traffic because it's basically allowing from any source, all ports, all protocols are being allowed, right? So what happens is in the ACL, the rules are evaluated in order, right? Starting with the lowest number, okay? So lowest number is 100. Any packet will match this rule, right? Everything is allowed. So the packet will be allowed in, right? Now, if the rule does not match, then the default rule is applied, which is deny, right? So the default rule is the one that actually blocks or drops the packet, okay? So what you should be doing really is not doing this, right? This is ineffective. What you should be doing is, first thing is to delete rule number 100. You should delete this rule because this rule allows everything in, right? So delete this rule, okay? And instead create more specific rules. For example, you might want to allow port 80 HTTP traffic, right? You might want to allow RDP traffic. You might want to allow SSH traffic in from certain restricted sources, right? So all those types of rules you'll have to create, all right? At the same time, you have to delete this rule, but never delete this rule, right? Don't delete the default rule because this is the one that blocks your, drops your packets, okay? So default rule should always be there. Don't delete that, but definitely delete rule number 100, okay? All right. Now, when you create your rules for allowing HTTP or SSH or RDP traffic, right, give them a number, right? So rule number 100, 101, it doesn't have to be, consecutive, right? It doesn't have to be 101, 102, 103, nothing like that, right? You can create rule number 100, rule 110, 120, 130, that's fine. But normally you want to leave some gaps because that way you can introduce new rules in the middle, right? So it's important to do that because the rules are evaluated in order, okay? So the lowest rule is evaluated first, the next number, and so on, right? If a rule matches the particular packet, then no further rules are evaluated, okay? No further rules are evaluated, right? If no rule matches the packet, then the default rule applies, which means the packet is dropped, okay? This is how the ACL works. It works a little bit differently from the security group, all right? Okay, today we're not changing this, okay? Today we are not changing the ACL, but remember what I said, delete the default rule, but delete the rule number 100, but don't delete the default rule, okay? Don't delete the default rule, delete rule number 100. Okay, all right. Okay, so I think one of you has some audio problems, right? I hope others are okay. Let me just let Shyam know. All right, so let me, okay. All right, okay, folks. So this was the ACL, right? This was the ACL, and you have to fix this, right? Right now we're not doing this, but later you should fix this. All right. Okay, so now let's launch a server. Right now we are interested in launching the server, but like I said, first we have to create a security group for this web server. Right. So let's do that. So let's go into security groups here. Right. In the VPC, you also have security groups. Let's create a security group. Okay, and I'm going to say scenario 2. Let's say this is web server security group. Okay, so this is going to be the name of our group, and this is going to be in this particular VPC. This is an important step, right? Your security group should be created in the specific VPC that you want to use. Okay, so we select the scenario 2 VPC that we had created. All right, now this is going to be our security group, right? And here let's create inbound rules, right? This is very similar to what we have done before, right? So number one, let's say we want SSH traffic, right? We want SSH traffic, and let me get my IP address. Okay, so this is my IP address at the moment, and I'm going to say IP address /32. So /32, is a network mask, right? And that says one host, right? Only one machine is in this range. Okay, so that's what that means. So this is one rule, right? And let's also add another rule, maybe HTTP. Let's say this is a web server. So here we can say something like this, right? So unrestricted access, but only on port 80, right? And restricted access on port 22, which is, we've seen this before as well. Okay, you can also do more. You can create maybe HTTPS if you like, right? So these kinds of rules you can create. Okay, all right. So now we save. Now we save this, and so now we have a security group within this VPC, right? This is a security group within this VPC. Okay, and now we are ready to launch our web server in this VPC. Okay, so let's go ahead. I'm going to go to EC2. All right, let's go to EC2. And let's launch a server, the usual stuff. We've seen this before, right? This is something we've seen before. Let me use the Ubuntu server as usual, right? And we'll select micro as usual. Okay, now this was the page which we left alone previously, right? We didn't really change anything here in this page, right? Now this time, what we're going to do here is we will select our scenario 2 VPC. Okay, so let's select scenario 2 VPC. Okay, also make sure that you choose the right subnet. Remember, there are two subnets, and we want this server to come up in the public subnet, right? So let's select this one. Okay, so this is the important step here. Select your VPC, select your subnet for this particular server. All right, okay. Now also remember, in the same page, you can choose to have dedicated instances, right? Now remember, this is, you may have a regulatory requirement. There's lots of, in banks in this country, for example, banks are required to run on dedicated hardware, right? So you can choose that. This is another feature of the VPC, right? The choice, the option to have dedicated servers. You can choose that, all right? But this will be more expensive because you're not sharing, right? This will be more expensive. Okay, so that's the big difference, right? That's the big difference from the previous demonstrations that we have seen. All right. Otherwise, everything is the same, right? This is EBS. Yeah, security group. You have to select the one that we just created, right? This is the one that we just created. So make sure that you select that security group, right? And now we can launch. Now we can launch this server. All right, now, right, the server is coming up. We'll just test it quickly, or maybe we'll do an SSH, right? We'll do an SSH to the server, right? Now, to do an SSH to the server, we normally need a public IP address, right? Now you can see there's no public IP address here, right? There's no public IP address here, okay? Now this is the default behavior of servers in a VPC. This is how it should be, right? A VPC is meant to be a private network. It is not meant to have public IP addresses, right? So that's why this is the default behavior. You don't have public IP addresses. You can change that, okay? You can, when launching, you can say, yes, please assign a public IP address to the server. You can do that when launching, okay? But by default, servers in a VPC don't have public IP addresses. Okay, in the previous demonstrations, they had public IP addresses because we were using the default VPC, right? Only in the default VPC do you have public IP addresses created by default, all right? Normally, no public IP addresses, all right? Okay, so anyways, in our picture here, what we want is a elastic IP, right? We want an elastic IP address. So instead of using a public IP, we'll allocate and associate an elastic IP. Okay, so let me create another elastic IP. Right, this is the second one. The first one was associated with the NAT gateway, right? And this one has to be associated with the server. All right. Okay, so let's associate this, right, with our EC2 instance. All right, so that's done. That's done. Okay, so now our instance should have a public IP. This is basically the elastic IP, right? It's the same thing. Elastic IP is also public IP, so we use this IP address, and now we can do an SSH as we have done in the past as well, right? So just use the private key, use the right username @ elastic IP address. Okay, so this is our Ubuntu server, right? You can test it out. You can run your usual Linux commands, right? And then you can exit using the exit command. Okay, so our demonstration is complete, right? But what you have to note here, right? What you have to note here is that for the connection to happen to the web server, we actually had to, it's quite complicated, right? There are many things to sort of navigate. First of all, the subnet has to be a public subnet, which means in the subnets route table there should be an internet gateway, right? This is the internet gateway. Without this, we cannot connect. There's no network path. Okay. Next, to get in, we have to cross the network ACL, right? The firewall at the network level, right? Right now it's ineffective. Right now it's allowing everything, but normally you'll have some rules there. So your request SSH connection has to pass through the network ACL as well, right? And finally, your security group, which is protecting the particular EC2 instance, right? So you have to have rules which allow your request as well. Okay, so there are 3 barriers that you have to navigate. The internet gateway should be there, right? The subnet should be a public subnet. You have to have a ACL rule that allows your request, and then the security group has to allow your request, right? So there's a lot of protection, and that's why a VPC is good. Okay, now later, tomorrow in module 5, we'll see how to launch database instances, especially RDS instances, in a private subnet, right? So that we'll see later, okay? But yeah, that's it, right? This is the demonstration on VPC, okay? So let me stop here. Let's spend the remaining time. We have about 15 minutes. Let's spend that on any questions you may have on the implementation, right, of the scenario to VPC. Okay, so any questions on the VPC wizard, any questions on how to launch a server in the public subnet, right? Any questions on the components of a VPC, please let me know. All right. Okay. Okay. So this question I think we'll do after the after this VPC discussion. Okay. So this we can do it in the review section that we have. All right. So let's wait on this one. Any questions on the VPC side? Please let me know. Okay, let me just look at this one, right? Uday, you mentioned that you want bidirectional for database requests, right? You want bidirectional for database requests. No, but see, you that means you're trying to connect to your database from the outside, right? That doesn't that's not a good. That doesn't seem safe, right? So here. Uh, So here, the question is, why do you want to connect? Why do you want to connect? Why do you want to connect to your database from the outside, from the internet? That doesn't sound good. Okay, that doesn't sound good. So you should connect from servers within the same VPC, right? Your app server should be in the same VPC. Okay, it should be the same VPC, right? Now, if you want to connect just for maintenance of the server, you should use the VPN connection, right? So there's no need, there's no case here. So I don't think there's any need for bi-directional connectivity to the private subnet, right? So based on above, it doesn't look like. So there's no need. There's no need for bi-directional connection to the private subnet. Okay, so there are other ways of doing what you need. This is not how you should be doing it. Yeah. So this question as well, Bailan will discuss after the VPC discussion. Okay. So we'll spend some time after we finish this session, so we can do it there. Okay, so this one, Rao, if you have a VPN connection, how do we configure routing rules with respect to IP addresses? Okay, so you can use the wizard, right? Use the wizard and select. First of all, select scenario 3 and 4, right? 3 or 4. Right, and which IP addresses, right? Which IP addresses are you referring to? Are you referring to your corporate network IP addresses? Right. So let's see. Let's try and create this. So let's try and create this one. Right, scenario 4. Okay, so this is going to be your, you have to configure the VPN here, right? So we can't do it now because you need some equipment, but basically this is going to be the public IP address on your site, right? This is going to be the public IP address on your site. This you have to have. It has to be a public IP, a static IP, right? This your ISP will have to provide to you. Right? So this is the main thing. I think this is the main thing. Once you get this, everything else should be fine. Right? So let's see if I can give this one. But let me give this one here and see what happens. So this is my It's not a static IP, right? But let's see. Okay. Okay, so that's it. Just make sure that you have a static IP, public IP on your side, right? And that will be assigned to the customer gateway. The customer gateway is a component on your side for the VPN connection. Okay, so basically from this wizard, right? What you are seeing here is let's say for scenario four, right? The customer gateway IP address. Right? This should be a public static IP address on your side, right? Your ISP, right? Your ISP should give you this IP address, right? So that's about it, right? Let me know if you have any specific question. Okay, let me know if you have any specific question on this. But it looks like it will create it. Right? It looks like it will create it. Now, I can't show you this fully because I need a VPN connection on my side, and it's a bit tricky. Okay, but also there'll be lots of documentation. Okay, so scenario 4 and 3 will be well documented, and you'll find all the required information. Right? Let me know if you have anything specific beyond this. Yeah. Okay. All right. Okay, folks. So I think that's it, right? I think that's it. Now let's talk about the other questions. Maybe Git or this one here, own cloud app. We can talk about those if there are no further questions on the VPC. All right. Let me know. We still have some time. If you still have questions on VPC, please It's a very important topic. Okay. I think now it looks like we're not able to create servers outside of VPCs, right? So you have to use VPCs, especially scenario 2, right? Also maybe scenarios 3 and 4, because a lot of you may have to use VPN connections. All right. Let's also talk about what's coming up next. Right? Let's talk about what's coming up next here. Okay, so from tomorrow we'll start module 5, right? So we'll need 3 hours for this module 5, and normally, just like module 3, we need more time for database services, right? So tomorrow and day after, we'll probably spend on module 5, which is database services, right? And here we'll talk about 4 services: RDS, Relational Database Service; Dynamo DB, which is a NoSQL service; Redshift, which is a data warehousing service; and Elasticache, which is an in-memory cache. Okay, so 4 database technologies that you can include in your architectures and designs. Okay, and it's important to look at these 4 technologies because in the cloud it's possible to use all 4 technologies. Right? Normally, what happens is before the cloud, if you mastered one database technology, that itself was a big deal, right? Because you needed expertise, DBAs, those kinds of things. Most people, it's not possible to have to learn and use and implement multiple database technologies, right? But in the cloud, it's simple, okay, because most of it is automated. You don't really need DBA type of expertise, right? You can do fancy stuff like replication, automatic failover. All those things can happen on the cloud very smoothly, right? And because you don't need too much of expertise and effort, you can actually think of using multiple database technologies in your applications, right? So one application can have a NoSQL database and a relational database and Elasticache in-memory cache, right? And also you can have Hadoop, and you can have Redshift data warehousing as well, right? So it's possible to have multiple database technologies in your stacks, right? So for that reason, this module, upcoming module, is very important. So you can read up on these 4 services: RDS, Elasticache, DynamoDB, and Redshift. All right, so that's coming up from tomorrow, and we'll probably need 2 sessions for this. All right, okay. Okay, yeah, let's also talk about direct connect. Yeah, so I think that's a topic we can discuss for the next 5 minutes, and then we'll do the review. Okay. This question as well, let me answer. How did you get this customer gateway IP address? No, I just did, what is my IP address? So what is my IP address gives me the IP address of my network at this time. All right, so this is not a static IP. Okay, this is the public IP address that has been leased to my home network at this time. Okay, normally if you want a static IP, you have to tell your ISP and you have to pay for it. Okay, but this is the IP address at this time. Right, so what I did is just copied this. You can just type what is my IP on Google. It takes your from the web server request, right? From the web server request, it takes your IP address and it shows you this IP address. All right, that's what we've been using. So this is the Google for what is my IP. All right, this is the public IP of my network at this time, right? This may change. It's not static. This is not static, but you can get a static IP by asking for it from your ISP. All right. Okay. Now, before direct connect, let me also answer this question. Okay. IPv4 and v6. Look, v4 is the traditional IP, right? Traditional IP address. Something like say 192.168.1.1, right? Something like this. This is a traditional IP address, and v6 is much longer. It's much longer, right? It has a certain notation. But the main point is that V4 are older. When this was defined, nobody thought that we will have so many IP addresses, right? And what's happening is V4, the world is running out of IPv4 addresses, right? So we just don't have enough V4 addresses. And it may soon become a crisis, right? Soon become a crisis. So V6 is a newer standard, a newer way. Basically, it's much longer. It can support much larger IP address sets, right? And for the foreseeable future, V6 will be sufficient, right? That's what it is. And V4 we have to get out of. Okay, but getting out of V4s is hard because there's lots of changes that has to be done at the ISP levels and so on. Okay, so we're not. The world has not moved to V6 yet, but we have to move to V6 soon. All right, that's the situation. Okay, we have to move to V6 soon. Right now, AWS is gradually adding support for V6. Right, some services support V6, some don't support V6. For example, I think EC2 still does not support V6, whereas S3 does support V6. So that's broadly where we are. All right, so you can work with V4 for the moment, right? But V6 is coming up pretty soon. All right, okay. Let's talk a bit about Direct Connect, right? Let's talk a bit about Direct Connect, just a couple of minutes, and then we'll do the review of week 1. All right, Direct Connect, right? It's a networking service. That's why we're talking about this in this module. And what it is it's basically a leased line. It's like a dedicated network between your corporate network and the AWS region, right? So it's a direct connection, bypassing the internet, right? Bypassing the internet. Okay, direct connection, like a lease line, That's what it is. That's it. Okay, it's a infrastructural element. You have to sort of speak to an AWS partner, local partner, to see if they can extend that line to your office, right? This may not be available in all cities. You have to check whether Direct Connect is available in your city, right? And if it is there a partner who can come and help you and set up a direct connection to the AWS region? All right, that's what it is. and there are multiple speeds available, and we can look up the pricing, right? But mainly, what are the benefits? Why should we use this, if at all, right? So most people don't use it, by the way. Okay, most people don't use it. Most people don't need it. Only some of the larger customers, some heavy users, right? Perhaps they need to use it. Okay, but the main benefit is first of all, consistent network performance. Okay, what happens is when you use the internet to connect to AWS, the internet actually is highly redundant, right? So, for example, let's say your server is in the US, you're connecting from India, right? And your traffic may flow, via say, to the east, going from say Mumbai, then West Asia, right, somewhere near Saudi Arabia, then further west, right, maybe Europe, UK, and then to the US, right? So the packets will flow in that fashion somehow. The undersea cables will be used near Saudi Arabia, maybe, right? Then overland, then so on. So it flows like that, right? Now let's say there is some problem. Let's say one of the undersea cables has been cut, right? This happens. So the internet is very redundant. The network will automatically readjust, right? And it flows from somewhere else. Maybe this time it will go via from the east, right? So previously it was going west. Now it's going east via say Singapore, Hong Kong, Japan, and then to the US. Okay, so it can automatically change, and it keeps doing that, right? The network keeps switching from one path to another depending on the conditions. So this leads to inconsistent performance. Okay, your network performance is never consistent when you use the internet. So you may have certain applications which need consistent network performance. Okay, maybe like a real-time chat, a real-time gaming, those kinds of things, right? So that is one reason. The other reason is your bandwidth cost may be too high. Right? You may be a very big user of AWS, right? You may be transferring lots of data up and down over the network. Your regular ISP pricing may be too high, right? So you may want to consider using direct connect there as well. All right, and also you can think of this as having better security because it's bypassing the internet, right? On the internet, people can eavesdrop, right? This is a direct connect, so you have a better security as well. All right, so that's it. You can look up the pricing, and you have to look up, this is a slide on the pricing. Depending on the speed you select, you have different prices per hour, right? You can compare this pricing with the ISP pricing to see if it makes sense to do something like this. All right, but remember, it's not available everywhere, and you need a local partner to sort of create that direct line, the last mile, right? You need a local partner to do the last mile from your office to their connection point. Okay, so that's direct connect. All right, okay, folks. So now let's stop this module, right? Let's finish this module and let's talk about the review, right? Let's talk about. All right, let me just answer this question, and then we'll talk about we'll do the review. Okay, so Babita, direct connect, then it's not available anywhere since it is dedicated line for particular location of. No. It's available in certain cities is what I meant. Okay, so direct connect may not be available in all cities in the world, right? But if it is available in your city, then you can get a local partner to see. They'll have a termination point, right, somewhere in the city. Say Bangalore, right? Let's say the termination point is in MG Road. Your office is in Koramangala, right? So you need someone to come and do the last mile for you. Okay, if it is available in your city. All right. Okay. Yeah. So if you're in a different location and if you don't have a direct connection there as well, yes, you will lose the direct connect. Yes, that is true. So if you work from multiple locations, you will not have access. You will not have access to that direct line. Yes. All right. Okay, folks. So let's do a review, right? And now some of you may want to leave. You may have calls and work and all that, right? So please feel free to do that, right? Those of you who have questions, right? You can maybe stay back. Let's spend maybe, I don't know, 15-20 minutes or more, right? Depending on the number of questions. So let's use this sheet. Let's use this sheet. Maybe you can copy your question, right? So like this one here, Valen, you can copy your question, paste it there. And I think Gajendra, you had a question as well. So you can just copy it here, and let's do it here. All right. Okay. All right. So let's do this one by one. So Vaibhav, if you launch WordPress, do we have some exercises step by step to practice on EC2? Yeah. No, so look, instead of someone in Edureka creating this, right, you can use on the internet. There are many tutorials. Okay, there are many tutorials like this one. If you select, let's say, WordPress, right, on Ubuntu, right? If you're using Ubuntu, okay, depends on what you're familiar with, right? So use what you're familiar with, Ubuntu, Red Hat, whatever. So if you're on Ubuntu and if you choose this version, right, Ubuntu 14.4, then there's this link here, right? Article from Digital Ocean, right? So this is good. This is a step by step. Nothing more is required, right? But just be careful on the environment, right? This will work on Ubuntu 14.04, right? And if you choose some other version or some other operating system, then you need to look for some an appropriate link. All right. So just make sure you find make sure to find a tutorial for your environment, right? For your environment, operating system, OS version, right? So that's the usual problem, right? If you know your environment, your operating system and version, then you can find a tutorial quite easily, all right? And there are very good resources on the internet. Okay, this is best. Instead of Edureka creating something and maintaining it, right? This is the best way to do it. All right. Next question in round 53 is chargeable as I was unable to use while I launched WordPress as it was chargeable to create a record set. Yeah. So I think there may be some free, but you have to register. See, first of all, you need to register a domain. Right? You need to have a domain, or you need to register a new domain. Okay, this will cost you upwards of I think $12 per year. Okay, so don't do this. This is not necessary, right? This step is not necessary. This step is not necessary, right? If you don't have a domain, don't. I mean, if you want to practice, you can do it, but it's not necessary. All right, just use the Elastic IP and test your WordPress site. Okay, that's enough. So you can test using the Elastic IP address. There's no need to mandatorily create a domain. All right, now on the charges, you can look up the charges, right? If you have a domain, look up the round 53 pricing, right, and what is covered under free tier. You may be right. The hosted zone, I think, is $50. Okay, I think what I remember of the pricing is one hosted zone. One hosted zone is $50. Okay, that's not much, right? So it's $50 per month, something like that. Okay, otherwise the requests and all that will be cheap, and you'll have a free tier. So you'll have like 1 million requests free of cost. Okay, so requests will be free, but the zone itself is $50 per month, not much. All right, let's look at this question. Can you advise after downloading Putty how to configure to launch Windows Server created as EC2 instance? No. So look, here, let me just remove this one. Okay, look, there are two things here. You need Putty. Okay, Putty is an SSH tool. Okay, Putty is an SSH client software. Okay, it's a client for SSH. SSH is required only if you have a Linux server. All right. Okay. So if you are launching a Windows server, then you don't need PuTTY. Okay. You have to use RDP. You have to use RDP, right? Which should be available on your Windows laptop. All right. So it's very important to understand that what's on your server and what's on your own laptop or computer, right, has to be clear, right? The server is Linux, then you need SSH, right? On Windows client, on your own laptop, if you have Windows, you have to use PuTTY to do an SSH to a Linux server. You don't need PuTTY for connecting to a Windows server. All right, I hope that's clear, right? I hope that's clear. Yeah, okay, you can connect via RDP, right? So is your question on how to connect to a Linux server via PuTTY? Okay, fine. Yeah. So you don't need PuTTY for Windows servers, right? Because the operating systems don't they use different protocols basically for system admin connectivity, right? Okay, all right. Okay, this one, does Edureka provide self-paced learning course on networking concepts? So I think not Edureka, right? Not Edureka. But networking, look, it's I think you'll find lots of books, right? I think you can just go with Amazon and look for basic networking concepts. Let us say you'll find some books. You can look at the reviews and ratings and go by that. Right? I think that's what is is what I can come up with now. Right? Later, if I think of something, I'll let you know. But maybe you can just do that. Right? So look for networking books. Right? Yeah. So I think that's something. And then also on the internet, nowadays there's so much of information, right? If I think what you can also do is just go with the AWS tutorials, right? AWS has lots of tutorials on VPCs, right? And if you get stuck somewhere, or if you need to refer, right? You need to refer. Or if you don't understand a certain concept, right, then you can sort of look up on the internet itself. So in my case, at least, I just, let's say, I don't understand network mask, right? So just look up network mask. You'll find lots of information on the internet itself. So you can try that strategy as well, right? Not just go with the tutorials, and if you get stuck somewhere, then look up something that works as well, I think. Like that Wikipedia page on CIDR, right? That's a good one. That's a very good resource. So there's lots of resources like that. All right. Next question, Shyam. To connect to an EC2 instance, can we restrict to allow only key pair and not through user ID password? How is it done? Yeah. So by default, right, on Linux, the default setting on the OS is to use key pairs, right, and not passwords. Right? So it's already done for you. But if you are interested, right, you have to. It's an OS configuration. Okay, so what you have to do, for example, it's nothing to do with AWS. It's a Linux setting, right? So on Ubuntu, allow Ubuntu SSH, allow passwords, let us say, right? Root password, let's say. So you can just do a Google like this, and you can see here, right? So what you have to modify is there's a file called etc ssh config, right? You have to modify this file, okay? And this file will have lots of fields like permit root login, yes or no, right, to use password or not. So all those configurations will be in this file. Okay, so just go through this file. You can look up the man pages, right, manual pages, and do the configuration. So basically, it's an SSH configuration that you have to do, right? So you can configure SSH parameters, right, in the operating system. Okay, in the operating system, example on Ubuntu. On Ubuntu, the file is this one. Okay, so and normally when you change SSH configuration, don't forget to exit and re-enter, right? So you have to exit the session, after the change, and connect again, right? So then you will see the, let's say if you say force ask for a password, so you have to exit the session, log in again, it'll ask for a password, right? So that's how it is. Okay, next question. When creating an image, will it create a snapshot also for the volumes attached to the instance other than the root volume? Yeah, yes, it does, yes. Because, it is creating an image, of your server as it is at this time, okay, which includes any additional volumes, right? So it has to faithfully create your server, right? And faithfully creating a server means it has to have information about all your volumes, right? Because there could be some valuable data in the other volumes, right? So it has to do that. Okay, Shyam, suppose I want to use S3 for my database. How can I create a DB in S3? Is it possible? Any AWS APIs to do this? No. So first of all, what kind of DB? Right? What kind of DB? I mean, are you talking about Oracle, MySQL, right? So that's important to know. But in general, right? S3 is not a server. It's not a server, right? And for a database, you need a server. So databases cannot be run on S3. Okay, it's a very different kind of storage, right? First of all, it's a storage; it's not a server, right? S3 is not a server; it is only storage. It's only storage. So databases cannot be run on S3, right? Because you need compute, you need memory, you need RAM, right? Those things are not available in S3, right? It has, sometimes people mix it up because S3 supports a little bit, some web server capabilities, right? Because we can run a static website on S3, right? You can run a static website, right? So because of this, people think it's a server, but it's not. It's only a storage device, right? And it's not a server, so you can't run MySQL, you can't run Oracle, and so on. All right. But now, what is happening? What you may be interested in is this, that some newer services, right? Some AWS services, especially on analytics side, can create your analytics reports, etc., using data stored in S3. Okay, so you may have say files with data stored in S3, right? It's not a database, but the analytics engine can pick up that data and create your analytics, right? So in that sense, maybe you can say your S3 is becoming a database. Okay, so this data, however, is a file. Okay, so but in general, you can't run the traditional databases. You can't do that. All right. One more question here. So, would Edureca provide mock tests or access to sufficient practice papers, or can I buy it separately, or is it must to have 18 months hands-on on live project experience in a company? No. So in the LMS, right? In the LMS, in the last section, right? You will find a mock test, and it's pretty long, lots of questions, right? 80 questions or something like that. Okay, so it's available as part of this course. Okay, so that's available. But let me tell you one thing. Okay, the AWS exam questions, all right, are created with a lot of effort. Okay, it takes a lot of time to create these kinds of exams because the questions have to do the job. Okay, and the objective of the exam is to separate really experienced people with expertise from people who are beginners, right? So that's the job of the exam, and it takes a lot of testing, a lot of work goes into creating the exam questions. All right. Now, Edureka will have practice questions, right? But they will not have the same level of difficulty, the same effort, the same level of testing of the questions, right? Whether they are valid or not, whether they do the job or not, right? So that you have to know, right? So Edureka questions or any other source will not have the same validity, right? Or will not be the same as real AWS questions. Okay, let me just say that will not be the same as real AWS or official AWS questions. Okay, because it simply is not possible. It takes a lot of effort, right, to make a valid test, right? And these are only practice questions. Okay, so what I suggest you do is there are some sample questions. Okay, what you should do. This is sample questions, only 7 or 8 on the AWS site, right? And I'm going to do a mock test with these sample questions in module 10. Okay, we will do this in module 10. All right. There's also a mock test by AWS. Okay, it's $20. You can go and take a mock test anytime. You have to go to the center and take a test, right? So you can do multiple mock tests just to see where you are and also for some practice. Right? These are official questions, official mock tests, right? So this is what I would recommend you do when you're approaching the time of taking the exam. All right, okay, so this is how you should do it. And what else? Do you need a hands-on 18 months? So 18 months, let's say 12 to 18 months, right? This, I think, is very important, all right? It's very important because, otherwise you have to sort of treat it like a college exam. You have to, mug up, right? You have to do a lot of, look, without experience, you won't be exposed to nuances, right? You won't be forced to make decisions. You won't have to see when you come across a real problem. You have to read up, discuss with people, right? So the learning will not be as good, right? So I think that's very important, right? But if you don't have the opportunity, right? I understand a lot of people say this to me, right? They don't have the opportunity at this point. So what is the option? Well, the option is somehow, right, you have to manage with the reading and videos and self-practice, right, and these mock tests, right? That's the only way, right? Ideally, you get some experience somehow. Maybe you can volunteer somewhere, right? Maybe something like that somehow, or maybe in your own company, right? Like I said before, if you can champion AWS in your own company, that's one way of getting some experience. Okay, so you're about to start a solutions architect job. All right. Okay. Hopefully, you'll in this job you'll get the opportunity to use AWS, right? So yeah. So no, to get those, to practice for a few months, you have to use your network basically. Right? There's no other way. I think. All right. Okay, folks. Any other questions? Please let me know. Especially, if you have any trouble, if you've had any trouble with, say, EC2, S3, EBS, right? Especially these 3 services. Okay, let me know. Okay. Okay, folks. So if no further question, then let's end the session. Right? Let's end the session here. I'll see you tomorrow for module 5. Okay. Thanks for joining, and bye for now.